0.00 gram of hydrogen contains 6.02 times 10 raised to power 23. 1 gram atomic mass of helium is equal to 4.003 gram of helium containing 6.02 times 10 raised to power 23 atoms. 1 gram of sulfur is equal to 32.06 gram S contains 6.02 times 10 raised to power 23 atoms. Example 2. A. Calculate the mass of magnesium atom. B. Calculate the mass of magnesium atom in a sample weighing 1.0 times 10 raised to power minus 6, where Na is equals to 6.02 times 10 raised to power 23. H is equals to 24.30. Solution. A. 1 gram atomic mass of magnesium weighs 24.30 gram. Given 1 gram atomic mass of magnesium contains 6.02 times 10 raised to power 23 atom. Therefore, 6.02 times 10 raised to power 23 atom weighs 24.32 gram. Therefore, one atom weighs 24.32 gram over 6.022 times 10 raised to power 23. This we then have an answer as 1.67 times 10 raised to power 24 gram. To calculate the mass of magnesium atom in a sample weighing 1.0 times 10 raised to power 6, we have that 1 gram atomic mass of magnesium is equals to 24.30 gram, which is equals to 6.022 times 10 raised to power 23 atoms. Number of atoms of magnesium in 1 kilogram is equals to 6.022 times 10 raised to power 23 all over 24.30. Number of atoms in 1.0 times 10 raised to power minus 6 is now equal to 1.0 times 10 raised to power minus 6 times 6.022 times 10 raised to power 23 all over 24. Then the answer of the question will become 2.5 times 10 raised to power 16 atoms. Formula mass or molar mass. The formula mass or molar mass of a compound is the mass of correctly written formula or one molecule of that compound obtained by adding together the appropriate relative atomic mass of all the atoms of the elements present in the molecule. Example 3. Calculate the molar mass of calcium trioxynitrate 4 in grams. Solution. Calculating the individual molar mass of the elements involved, we have calcium 40, nitrogen 14, oxygen 16 times by 3, we have 48. Then times 2, since the two are this nitrogen trioxide are having two molecules, we now have 2 times 14 plus 48. Then this will give us 40 plus 124. Then the answer will become 164. Therefore, the molar mass of the calcium trioxynitrate 5 is 164 grams. Example 4. Calculate the molar mass of magnesium trioxosulfate 6 heptahydrate crystal in grams. Solution. Calculating the individual constituents that make up these elements, we will see magnesium, sulfur, oxygen, and water. Then, since there are 7 heptahydrate in the molecule, then we have magnesium as 14, sodium as 32, oxygen is 16. We multiply it by 4 since we have 4 molecules of oxygen. Then the water contains oxygen and hydrogen. Then the hydrogen have a molecular mass of 2, while the molar mass of oxygen is 16. Then since the water is having a heptahydrate, then it will have 7 element 7 atoms of it. Then you multiply 7 by the water. Then when you sum up all the individual molar mass that make up that element, you have 246. Therefore, the molar mass of magnesium trisulfate 6 heptahydrate crystal is 246 gram. Example 5. Calculate the molar mass of trilate tetraoxide 2 copper 2 tetraoxosulfate 6 pentahydrate. For the trilate tetraoxide, we have that 3 molecules are in lead, then 4 molecules are in oxygen. Then multiplying it by the molecular mass of each particle that make up that element, we have that 3 times 207 plus 4 times 16. Then what we're going to have is 621 plus 64, which will give us 86. Therefore, the molar mass of trilate oxide is 685 grams. Number 2. For the question 2, we are asked to calculate the molar mass of copper 2 tetraoxosulfate 6 pentahydrate. Calculating the individual constituents that make up this element, we see that copper, sulfur, 4 molecules of oxygen and 5 molecules of hydrogen oxide were involved. Then we have that 63.5 molecules of copper plus 32 gram molecules of sulfur plus 16 times 4 plus 4 times 4 molecules of oxygen plus 15 plus 5 times 2 plus 16 molecules of oxygen. Then we have 63.5 plus 32 plus 64 plus 90, which will give us 249.5. Therefore, the molar mass of copper 2 tetraoxopentahydrate is 249 grams. Example 6. Calculate the percentage by mass of sodium in aldehydrate sodium tetraoxosulfate 6. So, calculating each individual atoms that make up this compound, we have the molecular mass of sodium tetraoxosulfate, which have sodium, 2 particles of sodium or 2 atoms of sodium times its molecular mass, which is 23 plus 32 molecular mass of sodium times 16 molecular mass of sodium times 4 atoms of that sodium. Then summing the 46 plus 32 plus 64 will give us 142 grams. There are only 2 atoms of sodium in the compound. Therefore, the percentage of sodium in sodium tetraoxosulfate will give us 2 times 23 all over 146 times 100 over 1, which will give us 32.4%.